go over a computation of a Pearson R in simple regression. And then later on, I'll show you in another tutorial how to do this in SPSS. So let's, in our example, just use 5 observations. We would never do just 5 observations for a study, but if you have more observations, the calculations take longer. So we're just going to keep it simple for the purposes of teaching. Let's just say I wanted to see if we could predict depression by looking at disordered eating. For example, I want to look at scores. I have a participant take an inventory that looks at disordered eating, the extent to which somebody overeats or undereats, and I want to see if that predicts their mood, scores on depression. So each participant takes a disordered eating inventory and a depression inventory, and they get 2 scores, and they take these at the same time. And from these 5 scores, from these 5 different individuals, we can get a mean on disordered eating and a mean on depression, which is what I did here. We added 95, 85, 80, 70, and 60, added those items together, or the scores together, divided by 5, and we have a mean of 78. And we did the same thing for depression. Add those 5 scores together, divided by 5, got a mean of 77. Now to compute the standard deviation, I would take the raw score minus the mean. So 95 minus 78 equals 17, and that gives me my deviation score. 85 minus 78 equals 7, and that's my next deviation score, and so on and so forth. I do the same thing for depression. 85 minus 77 equals 8. 95 minus 77 equals 18. 70 minus 77 equals negative 7. So remember, we didn't want any negative values in our deviation scores, so we squared them. We get the squared values for x and the squared values for y. And I can use these values then to add them up, divide by the number of observations minus 1, so 730 minus divided by 4, 5 minus 1, equals 13.5093. So just to show that here real quick, I added up all my squared deviation scores, and I got a value of 730. And I divided that by 4. And then I took the square root of that value, and I get 13.5093. And I would do the same thing here. 630 divided by 4, square root, and I get 12.5499. So the next element that we need is what's called the covariance. We're not going to square anything here. We're just going to take the deviation score for x and multiply it by the corresponding deviation score of y. And that's going to give us a covariance for that individual. And we're going to do that for each participant. 2 times negative 7 is negative 14, so you see here. And I add all these up together. And then I don't square anything with these. I just take 470 and divide by 4. And that gives me kind of this standard covariance of 117.5. Okay, now I can take this value here, and if I divide it by the multiplied values of each standard deviation, I get my Pearson R. So I divide this value here, this 470 divided by 4, so this 117.5, I divide it by 13.5093 times 12.5499, close my parentheses, and I get 0.6931 right there. So now I've got my Pearson R. Now I can use these values that we've just computed to compute my beta weight and my intercept value. My beta weight is simply going to be the standard deviation of depression, 12.5499, divided by the standard deviation of disordered eating, 13.5093, and I multiply that by the Pearson R times 0.6931. And that gives me my beta weight, 0.6439, or 38. So really close here. All right. And now for my intercept value. My intercept value comes from the multiplied value of the mean of disordered eating times the beta weight, which is then subtracted from the mean of y. That becomes my intercept value. So if I take the beta weight of 0.6438 and I multiply that by the mean of x, 78, and that is then subtracted from the mean of y, I get 26.78. So just a little bit of rounding error there, but looks really nice, doesn't it? So everything's kind of coming out correctly. And so now I have everything I need in order to make a prediction. So, for example, if I want to know if I have a score of 95 on disordered eating, what am I likely to get? What am I likely to get as a predicted score? And it's not going to be perfect, but what we would do is so we know that y equals the beta weight times x plus the intercept. So the beta weight, 0.6438, times 95 plus 26.78 is going to equal 87.9452. All right, and so each of these values is what's predicted, just to kind of show you how the math works. So the value of x was 95 times the beta weight, 0.6438. All right, plus the intercept, 26.7808, and we get 87.94, which is what we have here. So you can see it works really well in terms of how we predict. Now, we have error in our prediction, don't we? That each predicted value is going to have error. And if we take what we predicted, so that's what we predicted, but that's not what we got. What we got was 85, and so this 87.9452 minus 85 is what we call a residual. It's what we call error. That what we predicted and what we actually got were different, and so we're going to have error with each prediction. And we can square those error terms and add them together and get this squared error term, the sum of squared error term. Likewise, we can take what we predicted, and sometimes if you have what you predicted and you know nothing else, you would subtract that from what the mean is, and in this case the mean is 77, and so what we predicted minus the mean, so 87.942 minus the mean was 10.942, and so this is what we call our regression scores, and we can take these regression scores and square them, and we end up using these squared values to compute the F value. So what we would do is we would take this squared value here and we would divide it by the number of predictors. We just have one predictor, disordered eating. So depression was predicted by only one predictor, disordered eating. So we take the number of observations minus the number of predictors minus 1. So 327.3973 is divided by 5 minus the number of predictors minus 1, which is 3. And it gives us its value of 109.1324. We're going to write that down. 109.1324. Because this value divided by this value is going to give us our F value. And I'm going to show you that in the next tutorial about how this F value or how this F test works in SPSS.